This is the answers to the Math 7 Unit 6 study guide on coordinate plane functions, graphing on the coordinate plane, graphing linear equations. Question number 1 says to graph and label each point on the coordinate plane and name the quadrant in which each point is located. Take a look at this. Essentially has to graph it. It's a little big, so I'm going to make it smaller. Give me 1 sec. For right now, this is a little bit better. Let me quickly label my x and y axes, and don't forget to label your tick marks. Now that I've labeled, I prefer to label the 5s. I'm going to quickly graph this. 0, 2 is 0, up 2. That's one that students often get wrong. 4, negative 1 is 4, up 1. That's B, don't forget to label. C is to the left 3, up 5. To the left 4, down 1, that's D. E is to the right 6, up, down 0. F is the origin, 0, 0. G to the left 3, up 1. That's G. H is to the right 9, which is 5, 6, 7, 8. And then up to there, that's H. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, a little off. I is to the left 3, down 2. That's I. And then J is 0, down 6. That's J. Now since the name of the quadrant, 0, 2, that's none. You could say none, or you can say it's directly on the y-axis, but it's not in the second and third quadrant. B is in the first quadrant. C is in the second quadrant. D is in the third quadrant. E is again none, or you could say the x-axis. And this is again none for F, or the origin. G is in the second quadrant. H is in the first quadrant. I is in the, again, third quadrant. And J is again none for the y-axis. Ironically, none of them are in the fourth quadrant, but the fourth quadrant would be IV in case you are interested in that. Number 11 asks us to use the word pairs to make a list of the domain and range. Is it a function? How do you know? The domain is all of the x's, which is 1, 7, 0, 2, 9, negative 2, and 5. So again, it's 1, 7, 0, 2, 9, negative 2, and 5. The range is simply the y's, which would be negative 5, 3, 2, negative 2, another 3, so I would not list it again. 4 and 5. The difference is there's one repeating one. Again, you don't write it more than once. Is this a function? The answer is yes, it is a function. And you say each x has one y. So it is. 11a, can the coordinate 6, 8 be added to the list to keep it a function? Well, since there is no 6, that would be okay. So yes, you can, because 6 does not repeat anything. Number 12, is it a function? Definitely not, for 2 reasons. 5 has 2 outputs, and also these have no inputs. So it's not a function because 4 has no output, 3 has no output, and 5 has 3 outputs. In order to be a function, each x has to have exactly 1. This has 1, this has 1, that has 0, 0, and 3. It is not a function. So you can say no, 5 has 3 outputs, or no, 4 has no output, and 3 has no output. Number 12, again, listing the domain and the range. Use the relation to make a list of the domain and range. The domain is all of the x's, so it's negative 1, but I see negative 1 again, so I don't list it again. 0, 2, negative 3, negative 5. The range is all of the y's, which is 2, 4, a 5, and there's multiple 5s, so I'm not going to list it more than once. And another 2, I'm not going to list it more than once. Is this a function? The answer is no. And why or why not? It's because negative 1 has 2 outputs. In other words, negative 1 is with 2 and negative 1 is also with 4. It's not okay, and it's not a function. The y's don't matter, it's just the x. How do you know when a relation is a function? Again, each x has to have exactly 1 y. X's don't cheat. And each input has exactly 1 output, not 1, not 0. That's sort of what we're looking for with this example. 14 is asking us to make not a function and a function. Well, if it is a function, that simply means that there are no x's above each other, the graph does not cross above each other. So I could do it like that, or I could just make a whole bunch of points as long as none of them are directly above each other. If it's not a function, that means somehow points cross over each other and fail the vertical line test. I could also do it like this. There are 2 points that are above each other. Again, 2 points that are above each other. It means it failed the vertical line test. 15 is similar, asking us to fill in what is a function. A function just means I can do this. 2, 3, 5, 7. As long as the x's are different, I can have the same y if I want, as long as the x's are all different. But of course, if I have a repeating one, let's do 2, 3, 5, and then another 5, and then I do 1, 1, 7, and 6. Now 5's with 7 and 5's with 6. It cannot be a fraction. If I did 1 and 1, this would be okay because this is really the same point. But if I had like 5 and 4, 5 is with 1 and 5 is with 4, this is not a function. Graph creating a table. In order to create a table, I need to choose my inputs, my x's, to get my outputs or my y. What inputs are we going to choose? 2, 1, 0, negative 1, and negative 2. I simply plug in. One of the tips for this, and students often get this wrong because they see this negative and it messes them up. You can also think of it as instead of y equals negative x minus 2, it's really negative 1x. So it's negative 1 times x. And that may help you. It's negative 1 times x. So it's y equals negative 1 times 2 minus 2. Negative 1 times 1 minus 2. Negative 1 times 0 minus 2. Negative 1 times another negative 1 minus 2. And negative 1 times a negative 2. I suggest you do the work on the side. Negative 1 times 2 minus 2, which is negative 2 minus 2. It's not 0. You do keep, change. That's negative 4. The next one, negative 1 times 1 minus 2, which is negative 1 minus 2. Keep, change, they work together, negative 3. Negative 1 times 0 minus 2, which is 0 minus 2. Keep, change, that's the additive identity, negative 2. You should be noticing a pattern. Negative 1 times negative 1 minus 2, which is a positive 1 minus 2. Keep, change, negative 1. Let's do the last one. Negative 1 times negative 2 minus 2. Negative 1 times negative 2 is a positive 2 minus 2, which is, of course, 0. So there is a pattern. We should see it on our graph. Make sure you label x and y. 5, 1, 2, 3, 4, 5, negative 5, negative 5. And let's graph it. To the right 2, down 4. To the right 1, down 3. 0, down 2, left 1, down 1, left 2, up, down 0. As you can see, it's 5 points. 5 points is not your answer. You need a line. This is not a line. That's called a line segment. Make sure you have arrows on the ends. Another one asking me to make a table. This one's almost easier than the first one. X and Y, looking for my inputs, 2, 1, 0, negative 1, negative 2. So it's 2 times 2 minus 3, 2 times 1 minus 3, 2 times 0 minus 3, 2 times negative 1 minus 3, and 2 times negative 2 minus 3. Let's do this work real quick. 2 times 2 minus 3 is 4 minus 3, or 1. 2 times 1 minus 3 is 2 minus 3. Keep, change. It's negative 1. 2 times 0 minus 3 is 0 minus 3. Keep, change. It's negative 3. Should be noticing a pattern. 2 times negative 1 minus 3. Negative 2 minus 3. We don't do subtraction. We do keep, change. It's negative 5. 2 times negative 2 minus 3 is negative 4 minus 3. Keep, change. Negative 7. We do want to label, so let me label very quickly. And now that I've labeled my x and y axes and my tick marks, I'm going to graph this. To the right 2, up 1. To the right 1, down 1. 0, down 3. Left 1, down 5. And left 2, down 7. It's not just 5 dots. It is a line. A line with arrows on the ends is your answer. A line with arrows on the ends. Number 18 says to identify 3 ordered pairs located on the graph. This should be pretty easy. We just want to find some coordinates some spots where it actually works. To me, it looks like these are coordinates that are actually on the line. The rest of them are close, but no quite cigar. These are on the line. This is the coordinate 0 up 3. This is the coordinate to the left 2 up 0. Sorry, right 2 up 0. This is the one to the right 4, and then down 3. So that to me are the 3 coordinates that would be on this line. Number 19. Write the rule that explains the pattern, then determine the equation. Finally, complete the table for the missing values. So writing the rule to me looks like, well, from 4 to 9, I could just think about adding 5, but if I add 5 here, you can't add 5 there, and you can't add 5 there. That's not working for the second two, so it's not as simple as adding 5. It's got to be something else. So maybe it's some multiplication type thing. If I multiply this by 2, I end up 1 short. If I multiply this one by 2, well, hey, it's not quite the same. It's not the same thing, but it's 1 short. And if I multiply this by 2, it's 1 short. So it looked like I multiply 2 times 4 and then add 1. That would give me the 9. And if I take 5, multiply that by 2, and add 1, that gets me to 11. So it looks like the rule is multiply by 2, then add 1. That sounds like a rule to me that can get me from x to y. In other words, y is equal to take x, multiply it by 2, and then add 1. Multiply my x by 2, then add 1, that's equal to y. So there's my equation. Now I can use this to find the missing values. What could I multiply by 2 and then add 1 to get to 21? Well, you can guess and check and guess and guess and guess until you get it. Or you can just say, well, if y is 21, let me put 21 where y is and solve it. Minus 1, minus 1. 20 equals 2x. Divide by 2, divide by 2. So x equals 10. Well, that sort of makes sense, right? Because 10 times 2 is 20, add 1. So 10 was a number that will make it work. Let me back this up and just keep my equation, because that may help me with the next one. It says, what if x is negative 4? Well, I know I just multiply by 2 and add 1, or I could also just plug into my equation. Multiply, x is now negative 4, so put that in there. Y equals negative 8 plus 1, which is negative 7. Not negative 9, negative 7. So again, if you figure out the pattern, the hardest thing is really figuring out the pattern. Multiply by 2 and then add 1. Once you get that, you can write the equation. Multiply by 2 and add 1, and you can use that for later purposes. And the last question also asks us to create a rule, which is going to be an equation, really. Create a table of values, graph, and then a rule for Gordon's situation below. Gordon earns money during the summer cutting grass. He charges each customer a one-time fee of $5 for gasoline. So no matter what, you get charged a one-time fee of $5. He also charges $1 for every square meter he cuts. So it's $1 for every meter. If you do 2 meters, it's 2 times the $1 fee. If you do 5 meters, it's 5 times the $1 fee. If I cut 100 meters, it's 100 times the $1. So $1 for everyone. Oh yeah, add to that the $5 gasoline fee. So if you look at all of them, and what's staying the same is the plus 5, the times 1, but what's changing or varying is the amount of meters. So I can call that maybe x, the amount of meters, and that might be my equation. $1 for every meter plus a $5 gasoline fee. So I just did some examples, did some things that might work for me, and I plugged it in. So in other words, my rule is $1 for every meter plus a $5 gasoline fee. I switched them using the commutative property of multiplication, which I'm allowed to do. Again, it's $1 for every meter plus the $5 gasoline fee. Let's plug in some values. We want to do 2, we want to do 1. We can even do 0 meters. Usually we do -1 and -2 meters though. X is -1, -2. But let's think. Can you have a negative amount of grass? Can Gordon cut -1 meter? That doesn't really make sense. So -1 and -2 we're actually not going to have because they don't make sense. These real world situations you got to think. So let's go up then and do 3 and 4. Let's plug in. Y equals 2 times 1 plus 5, which is of course 2 plus 5, or 7. Y equals 2, sorry, not 2 this time, but 1 times 1 plus 5, because now x is 1, which is 1 plus 5, or 6. If you cut 0 meters, plug in 0, y equals 1 times 0 plus 5, 0 plus 5, which is 5. Y equals 1 times, well now we're going to cut 3, which is 3 plus 5, because 1 times 3 is 3, which is 8. And y equals 1 times 4 plus 5, which is 4 plus 5, or 9. Let's graph these points. 0, comma 5, that one. 2, 7, 1, 6. I have a 3, 8, and a 4, 9. So if you notice, it should be a, obviously, a parallel line. I'm going to draw an arrow on that side. Should I draw an arrow going that way? No. As I mentioned, this negative represents the amount of meters. And you can't have a negative amount of meters, so if you go this way, it implies that Gordon cuts a negative amount of meters. That doesn't make sense. So your graph actually goes right there. It's sort of a ray as opposed to a line. This is a very tricky type question, thinking of the rule, but it is something that you are responsible for knowing how to do.